お問い合わせください。
Thanks for joining us today. We'll get started in a minute here. Just letting more people in here.
All right, I think we'll go ahead and get started and let people join. All right, my name is Julia Potter. I'm the current president of Women in Mining here in Arizona, also known as WIM. We are a nonprofit organization focused on retaining and advancing women and other underrepresented groups in the mining industry, as well as educating Arizonans and our members in the importance of mining in their lives and in society overall. So this is our Dig In Lunch and Learn series, and this serves that first icon over here, Educate. Thank you all very much for being here today. Just a quick thank you to our sponsors. Our 2020 Platinum sponsor, 2020-2021 Platinum sponsor is Freeport McMoran. Thank you very much for your support. And then I'll hand it over to Megan to introduce today's speaker.
Hi, everyone. Here to introduce Jessica. Jessica is a part of business development for Restruction Corporation. Restruction Corporation is a contractor specializing in structural repair and strengthening. Markets they serve are commercial buildings, water infrastructure, such as dams, treatment, distribution, transportation infrastructure, such as bridges, airports, tunnels, and industrial facilities, such as mining power plants and heavy industry. She was a kindergarten teacher just before making the move to Restruction 3 years ago. However, she's been part of the company for over 15 years, as she's married to the Arizona Field Operations Manager. With that, please welcome Jessica.
All right, Jessica, I'm going to let you share.
Okay. Sharing. Okay, do you guys see my slide?
Yep.
Really? Okay.
Yep.
Perfect. Hi, well, thanks for having me today. I just wanted to thank WIM. I was a part of it, and this group of women just work tirelessly to advance mining and advance women in mining, and everyone who wants to be part of it. And I just couldn't be more honored to be part of a group like this. So thank you guys for actually having me today. So we're going to talk about durable repairs in corrosive environments, and I'm super nervous, so hang with me as we go here. Okay, perfect. So a little bit of our history. Our company actually began in 1975 by a man named Tony Murray. Tony Murray was a PE, so professional engineer, and he kind of helped found a lot of the International Concrete Repair Institute, some of those industries, and using repair materials like epoxies and resins and different things in the world of concrete. So what we actually do is we specialize in structural strengthening, concrete patching, and structural concrete repairs. This is our president. This is Tim Gumina. So Tim actually came to Restruction from college, and he is a metallurgical engineer from the Colorado School of Mines. And he has actually done a lot of work with ICRI. He's written several papers. He's done presentations as far as Italy in the world of concrete repair. And then Mike Wyman, we have other principals, but I'll just introduce you to a couple of them. Mike Wyman is also a metallurgical engineer from the Colorado School of Mines, and he has been with us a long time as well. And then his kind of area of expertise that he works in is actually the American Concrete Institute. And that has a big tie to the mining industry as far as concretes and those different operations. And this is Adam. This is my boss. This is who I work for. He is the Arizona division manager. He's a civil engineer from the Colorado School of Mines as well. Have you caught a theme there? We aren't picky. It just so happens that we were founded in Colorado, and we draw heavily from mining engineer type of schools. So Adam also is an engineer from there. And then this is how I found my way into restruction and into mining. So I'm actually married to the field operations manager, like Megan said. He has been in construction for 22 years, and he actually joined Restruction in 2008. He came from Freeport-McMoRan's Millennium Mine in Henderson, Colorado. So our love for mining began years and years ago, and then the combination of mining and concrete repair is kind of how we made it to where we're at now. So some of the topics that I'm going to cover today are what is a basic concrete repair or steel repair in a corrosive environment, how we do what we do, working at keeping like a mine or another structure up and running while we are actually doing the work, and then what materials allow for these type of repairs, and then why what we do matters. So let's look at a couple of projects that we've actually done. So this is a sulfuric acid tank in Arizona. And what is happening here is the acid is leaking down from their SXCW, from their processing. And it is corroding the coating, and then it got into the concrete. And once the acid gets into the concrete, it can get into the ground. So we want to protect not only the structure, but the ground and anything that's underneath it. So these are kind of some before and afters of our repair. So what you can see here, what is happening is when this acid gets on the coating and there is any kind of failure in the coating, it gets underneath it and it causes this bubbling. So what's actually happening is the coating itself is coming apart from the concrete, but the concrete is also disintegrating. So it is falling apart. So what we do is we go in and we remove the coating and we take out any of the bad concrete. And then we want to use really, really sharp edges, squares, anything like that. We don't just lob it. And the reason behind that is in a durable repair like this, we want to have good exposed sides so that the new material that we put in is going to bond well and have a cohesive coating at the end. So the next step after we've removed kind of the coating, we've taken out any of the concrete that is delaminated or disintegrated in some way, shape, or form. We put down new concrete, and you can see the sharp edges. The goal here is not to remove and replace everything. The goal is to actually only remove and replace what is delaminated or what is no good. So that is why it's patchy as opposed to just removing the entire floor. And we'll kind of cover why we do some of that. Then we come back in with a coating over the top of it. So a mention on this concrete is this is not the concrete that you see in a ready mix truck when you're cruising down the road. This concrete is very, very specific to this environment. The reason we use specific concretes environments like this is number one, the mine isn't going to shut down for us. They're not going to stop running so that we can go in there and take 28 days for, standard ready mix to cure before we go in and coat it. So this specific concrete that is poured here is 98% sulfuric acid resistant. So it's not 100%, but it also has a really fast cure time. So we're not sitting and waiting 28 plus days in order to go and cover over this concrete to protect it. It is immediately, it begins to harden, it has a fast cure time, and we're able to go over it really quickly, being able to protect it even further. The other good part about a concrete like this, as opposed to like using a ready mix in an environment like this, is if there is a failure in the coating, this concrete itself is sulfuric acid resistant, meaning it's going to help prevent keeping the acid from getting into the ground or into whatever substrate is underneath it. Here's some good examples of what we geek out about, I guess is what you call it, is the still laminated concrete that is just literally crumbling and falling apart because of where the acid is getting into the concrete. And then you see this repair material is also a good repair material for vertical or an overhead. So we are able to use the same concrete on the flat surface as we are on the vertical surfaces. So that is also something special about it. Here's a beam. So the acid kind of drips down and it sits on this beam, and the machines are above it and they're being supported by that beam that is coming down and sitting on this column. So what is crazy is that you look at it and you think it's steel. It's not actually steel. That is fiberglass that they're using that isn't as susceptible to that corrosive environment. So we were able to just chip this out and replace it. And what you can see here is that it just goes back to what it originally was. It's not some new design. We are just removing and replacing what is bad. So here's an up close of that coating. And then what we're kind of showing here is that sometimes if we catch it early enough, and we were able to widespread across here, catch a lot of it early enough where the concrete wasn't bad underneath. So it's basically just removing the coating and replacing the coating. So that's kind of what we did there. And then here's kind of a big overview of how you can see that we just removed the bad spots, and it's a mining environment, so no one actually really cares that much how beautiful it is when we're done. But I still think the straight line stuff, they're pretty and I still get. So here's an example of some of those chemicals. If you have questions about them, or you want to know why we use what we use, or in kind of what other environments, if you just get a hold of me, I can let you know what any of these repair materials are. So the Yuko repair is the one we were talking about. That's the quick setting, low shrinkage. So I didn't even talk about why it's important. So when you pour concrete originally, it shrinks. So when we go in and we repair, we can't pour a concrete material that is going to shrink. Otherwise, it would be smaller than the patch itself. So we use specific materials that don't shrink in order to have it stay within the perimeters of where we've poured that repair back. So then we used a Hempel product. It's a 2-part component. It's a Novolac epoxy resin. And then we used a Neocrete, which this also has, and I took this off of them exactly, superb impact and abrasion resistant. So that is important in high traffic environments or really rough environments like a mine, that we choose a coating and a material that will not only stand up to the acids and the corrosions, but that we choose a material that will stand up to the abuse that is actually going to take. Okay, so here's a completely different environment. So this is actually a salt dissolving structure. So it's a brine room, and you can't tell from these pictures. We'll get to some other pictures when you see the sheer size of this room. So what actually is happening is you see the rust that's coming out here. Well, when we originally went into the structure, we just thought it was going to be kind of removing the coating, fixing a little bit of the concrete, but the rust was coming from somewhere and it looks like it's dripping down. So it doesn't appear as it's going to be like widespread corrosion. That isn't actually what happened. When we got into the structure, what is actually happening is rebar can expand something like 10 times its original size. When the water and the salt hit the rebar begins to corrode and it begins to expand. Well, as the rebar expands, it pops the concrete off. For us to do a repair like this, what we have to do is remove all of the bad concrete that's already popped off, because it's not going to stay on there later. You can't just coat over that. So we have to also chip back until we find good rebar, which would be rebar that looks like it's in its original state and its original size. Then we have to go a few inches past that before we can begin doing our repairs. Well, you can't just clean off rebar always. There is rebar that can be cleaned off. It's not gotten to that point. But in this case, the rebar was so corroded that we actually had to remove the rebar and replace it. Do that one of two ways. So something special about a contractor like Restruction or someone that does what we do is we actually have welders that work for us, and our welders have specific certifications to weld rebar, which is not your standard flat or upwards. It's a specific certification. So the other thing we use is couplers. Those will tie together the rebar as well. And as you can see, it's a vertical structure. So it's not when you're driving down the road and you see a flat structure where the concrete's all tied together. This needed to be sewn together in such a way that it would stay in that vertical structure. So the repair we did was actually shotcrete for part of it, and then part of it was a secacrete. And there are actually two different materials, but we were able to shoot this material onto the wall. Again, it's going to resist the salt, which is a totally different corrosion and the way that it operates as acid is on there. And you see again that we don't just do like wonky, spit figure, whatever. We square it up. We make sure that there is a good bond between the new repair material and what was originally there. And you can see that they're actually down in this hole. And then the last step is to choose a coating again that is going to withstand whatever the actual environment is. So these are kind of some information on the coatings. What is noted that's different about this coating that could carry over into a mine or someplace like that is this coating was intended to be submerged underwater. So it is a marine type coating, but it also has the formula to withstand the salts and the different things that are going to be in the water that is in this structure. So, and then like I mentioned, the secacrete 211 SCC, that's a polymer modified and silica fumed enhanced repair material. And yes, that's the same silica that we hear about with IMSHA on everyone all the time. Okay, so the third project I wanted to share with you, this one's down in Tucson. So it's not actually a mine, but what they do is when the cathodes at the mine are having an issue, they remove them and they either repair them or they replace them. So what they're actually doing at this facility is they're washing those cathodes. So the same acid is getting into their structure, which isn't necessarily on a mine site. So what happens is when they wash them over time, all of the coating has been just worn away in this trench drain that is right here. So this is kind of the before. So what we have to do in an environment like this is we go in and we remove whatever coating is left, and then we actually hand ground this, whereas the other projects we use things like jackhammers and so on to get a surface prep that we are looking for. So this actually is hand ground, so it's a really low profile. And then we take the same material that we're going to coat it and we thicken that up with fumed silica and we fill in the cracks. So if you see on this picture on the left, you see the big cracks. That is where this acid is getting into their structure and then into the ground. So what we're trying to prevent is not necessarily just the delamination of the structure. We're trying to stop that acid from getting into the ground. So what you see here is it looks wet. So this is the primer. So the primer we used on this one was actually clear, but you can see really good that we chase those cracks. So we grout out the crack in order to give us something to bond to. And what we also want to do is get to good concrete that doesn't have acid in it, because we don't want the acid coming up through the concrete. Otherwise, it's going to bubble our materials or repair materials. We don't want the acid going down. So we have to get this to the point where there isn't acid left in the concrete. So we fill in the cracks and prime it. And then this is the coating. So again, like I said, our goal at Restruction is we don't build things new. We don't just remove and replace. Our goal is whatever we do to return the structure back to its intended design. So they put the grates back on and it looks as if we've never even been there. So a couple of the materials are the same, but the guys in our office asked me to mention this Master Mako T 1061. This is a rapid setting cement-based concrete repair material with an extended working time. So what is actually happening here is this facility could have allowed us the time to use something like the 28-day cure. But money and time management wise, it makes more sense that while we're there to use a repair material that allows us to finish the job while we're there, as opposed to leaving and coming back. It costs more money and time and mobs and all of those things. So we take into consideration, if it was a long job that we're going to be there 30+ days, we would have used a cheaper material. But we were just repairing this one trench, needing to coat over it and move on to the next jobs that we had lined up. So the Hempel product is the same that we used at the other mine because it is that acid resistant, and what they're washing in there is that sulfuric acid. So a couple of the repair methods that we do at Restruction. I'm not going to show you all of these, but it just gives you kind of an idea of all the different areas in a structure that might need repair. So there's everything from concrete, PT, cables that might be nicked or something happened with them. We do injections, we do shotcrete, we repair tunnels, do carbon fiber, welding, dam, bridges, hydro demo, expansion joints, and overlays, and all of these things you will actually find on mine sites. So what is a concrete repair? A concrete repair should look like this. So this is a great example of where that rebar has corroded. It has popped off that concrete. We've gone in, we've repaired it, and we pour back the concrete to look like the structure originally looked, and it will hold the weight that it was originally intended to hold. We specialize in doing overhead concrete repairs. If you don't know what we do, you wouldn't necessarily look around and think, okay, how are they going to fix the concrete that's over our head. So when you're walking through a parking garage or someplace like that, and you see concrete that's falling down overhead, it actually takes very special or unique techniques in order to repair concrete that is over your head. So we do pumping, and sometimes we can drill pilot holes and pump down, but build special forms, because again, the goal is just repairing the structure. Welding and cutting. So this structure is a good example of something that might actually happen. And that is the original design of this building. They don't want to use it that way anymore. So they have this whole line of beams running down, or columns running down the center of the building, and they need those columns moved. So with engineers, we're able to go in, remove these columns, and transfer the load to the outside by putting new columns in the outside of the building, but clearing the way. And we actually had to remove these specific beams. Believe it or not, this is at ASU, through the ceiling with cranes. So we cut them, took the roof off, removed the beams that way because we couldn't go down. So that was kind of the engineering work that we did there. This is something you'll see quite a bit. So the original design, the concrete or the steel column is actually below grade. The water gets to it, it begins to corrode, and it compromises the structure and the strength. So what Restruction did is we weren't able in this specific structure to just remove it and replace it. So the other thing is the material that's being used here is very expensive, but it's a really, really hard PSI concrete. So what we did is we shored it up so that the building wouldn't come down, because now we've lost the strength here. And we came over, we removed the ground and the concrete. We just cut off that beam. We welded a foot onto it and then set it onto that high strength concrete, filled it back in, poured it back, and the building was able to continue operating like it was originally designed to operate. So this was another one. This one, the building was well underbuilt for the location it was in. So what the engineers designed, instead of changing the structure, what we actually did was we found where the columns are. We went in, we put this steel plate against the foundation, and then we welded the column to that steel plate, filled it all back in. They were able to just close the drywall back up, and no one even knew that we were there, but we were able to add the strength to the building this way without actually having to add more steel to the walls or bolt. So this is one of our favorites to talk about, because if you go to the Phoenix airport and you go down the T3 terminal and you see these big, beautiful white columns, these are those. What actually happened was there was a floor running in the center of these columns, and they wanted to remove the floor and expose it. So they also don't want to add bulk or mass to these columns. So what we did was we repaired the columns and then we strengthened them with carbon fiber. So carbon fiber is really good, not only in an application like this, but in other applications where you have a building that has one design intention, and then you want that building to be used for something else. So the manufacturers of carbon fiber in the classes that I took told me the best way of describing fiber is that it's like exterior rebar. It doesn't add the mass or the bulk, but it adds the strength. So we strengthen these columns so that the roof isn't coming down on everyone when they walk by. And then we fireproof them. And right now, when you see them, you see these big, beautiful white columns, and you would never know the amount of work that actually went in behind the scenes. So this was on a mine where this culvert or pipe or that ran under the ground wasn't designed for the amount of earth that was then piled on top of it. So that happens a lot in the mine, right? They begin digging one place and then they kind of adjust and move, and what's underneath it isn't always built to withstand what is now being put on top of it. So we are able to use carbon fiber in this structure as well to strengthen it up. We just built a special slide that kept the guys from actually touching the fiber, and did carbon fiber to strengthen the inside of this tunnel. This can be used in tunnels that are delaminating, they have other water issues and so on, and maybe you've done the repair, but you need the additional strength. So this is one of our favorite stories. The jail, the old jail in downtown Phoenix, is now the offices of the district attorneys. So they decided to take over the jail. So this whole building had to be remodeled. And because it wasn't originally designed to hold the weight of air conditioners and other things that are being put on top of this structure, we went in and added carbon fiber in this slab strengthening, basically, in order to shore this up so that they could use things like air conditioners and whatnot on top of this roof structure. So shotcrete is used a lot in those environments. This is a bridge. So you might see a lot of this. So this is not on a mine, but you'll see spillways like this or containment basins. So we use shotcrete and repair materials in order to kind of take care of all of that. And this is actually the Hoover Dam bypass. How many of you know that it caught on fire before it was ever built? And they had to hire a contractor to go in and repair what was fire damaged. And we're actually that contractor. So they had a fire from some welding. And because the river runs underneath it, it was enclosed. So the fire itself damaged the concrete. So you see these holes here. We did some core holes. We took all of the bad or compromised concrete out, and then we poured to make sure that it was good. And then we repaired this with shotcrete. So this is something that's really important to keeping a mine up and running, is actually shoring and jacking, believe it or not. We are able to shore up the buildings, and we spend time and attention of making sure that when we're doing these repairs, what our goal is to keep the mine running and operating as best as possible while we do our repairs. Obviously, there's areas in the mine that can't operate while we're working in them, but there's a lot of areas that can, and we do a lot of that through shoring and jacking. So this is that same building that I was telling you, and you can see it all the way across. We removed all of those steel columns. We're getting towards our end. This is one of our last ones. What actually happened here was a bridge was under designed, or it wasn't operating the way that it was designed to operate. So this center didn't actually exist. So what we did is we went in and we used these locking jacks to engage the bridge where we want it to be. We built this center and poured it out. And then when we let those jacks down, the bridge is able to come down to the level that it needs to be at. So why are companies like Restruction important? We'll get through that really, really quick. So cost. So I chose this to kind of give you an example of why a company like us would be so important in general to the mine, but into like the Department of Transportation or other things like that. This bridge was built in the 1900s to access the Kennecott mine in Alaska. And now it's just a bridge to nowhere. And then it was nicknamed the $1 Million Bridge because back then it cost over $1 million And it was the first engineering feat of its kind in an environment like that. Well, an earthquake, they didn't do the maintenance on it, and an earthquake hit and part of it fell. So I use this as an example of the cost to repair this bridge, which has to be repaired because of the coatings that are on it would pollute the water. It disturbs the salmon run. So the cost is so much greater in the end by not doing the repairs than it is on the front end by actually doing repairs. So shutdowns and access. So by doing regular maintenance and repairs with companies like ours, what mines are able to do is limit their amounts of shutdowns. And then durability and service life. So a company like ours coming in and just doing these regular repairs and maintenance items, it extends the life of the mine. You don't want to allow a structure to begin to deteriorate to the point that you realize there's 5 years left on the mine life, except for your SX is falling off. So we are able to go in there, and that is part of why what we do is important, is we extend the durability, because oftentimes the repair materials and the repairs we do are stronger than the original structure was, and then we just extend the service life. So something I am passionate about and why I kind of do what I do is actually natural resources. And when we do repairs, as opposed to remove and replace or tear down, we actually save on natural resources. So the amount of concrete that we use to repair those repairs you saw is minuscule in comparison to the amount of original concrete that was used to build those structures. So if we're constantly tearing everything down, it has nowhere to go, but using repair instead uses less resource. And that is why it's personal to me. So my husband and I, our favorite thing to do is go fishing in Alaska. So I am passionate about repairs, so that when bridges like the one that fell, they did repair that and they did pick it back up out of the water, is keeping the lakes and the rivers and everything safe for all of us. So that is it. Do you have any questions?
It looks like we had one question, Jessica, while you were talking, and that was from Daniel Stringham. And it was, does Restruction Corporation do mine shaft stabilization?
Not say that. I'm going to look at what he said. Yes, we do. We do. So if you have a mine shaft or something like that that you are concerned about and you would like someone to come out and look at it and have a conversation with you, by all means, reach out to me and we can have someone look at something like that.
Great. Okay, I think that's it for questions. Thank you so much, Jessica, for being here today. We really enjoyed having you. Thanks to all of our attendees for joining today as well. We are donating $1 to the Community Food Bank of Southern Arizona for each of today's attendees. So thank you again for taking the time, especially today. And then I also want to congratulate the winner of the $20 Amazon gift card, Mohit. We'll be reaching out to you after this to see the best way, the best way of getting that to you. And then please, if you haven't already, connect with us on LinkedIn. We also have an Instagram and Facebook accounts. We're also hosting a t-shirt design competition. We'd like it to be mining themed and to incorporate the WIM AZ logo. We have posted a link to submit your design on LinkedIn, and the winner of the competition will be receiving a $100 gift card to an Arizona-based small business. So a little incentive to participate. And then we've got a couple upcoming Dig In talks. In January, we'll be hearing from James Werner from the U of A's San Javier Mining Laboratory. And then in February, our speakers are from South 32, and they'll be talking about the Hermosa project. We do accept event-specific sponsorships for our Dig In talks. If you're interested, please contact us. Our email address is listed below there. And then finally, the U of A's Geotechnical Center of Excellence asked us to announce their 2021 Geotechnical Radar Monitoring course. There's some basic information about the course listed here, what will be covered, as well as the timeline, and then the contact information in the bottom right. Please reach out if you're interested. Thanks again to everyone for attending today. We'll see you in January.